Z-score is very similar to percentile in that we're trying to find a location in a number distribution, data distribution. So if we have a data set like this one, where we have a whole range of intervals, we actually have quite a lot of data here, so it's in a table form, not the original data set. So what we want to do is let's make a histogram just to get a visual of it. To do that, I'll put this into calculator. So I've already actually put it into the calculator. I'll show you the data here. What I have, and this is letting you know how to work with frequency tables in the calculator, is notice that the first value is 15, and over here we have an interval from 10 to 20. Well, the midpoint of 10 to 20 is 15. Midpoint from 20 to 30 is 25, so that's why the next one. So all these are the midpoints of the intervals. And L2 is where I put all the frequencies. So if we set up our stat plot and make sure our window settings are good, probably need to go from maybe 0 to 120. Now very importantly, now the X scale is the interval, and that's now set. We can't really play around with that. I mean, the interval is 10, so it can't really be anything other than 10 or multiples of 10. I mean, you could make it 20, I suppose. Now, Ymax is frequency. Our biggest frequency is 36, so I'm going to make it maybe 45. If we look at the graph, we don't see anything because I haven't set up the stat plot. We turn it on, going to choose histogram. And this actually is another difference from original data. Notice that the X list is L1. Frequency, when we have just original data, this has always been the number 1. But now, because we actually have a frequency table, L1 is our midpoints. Frequency is actually in L2. So now when we hit graph, there we have a nice histogram. And it looks like it's got a nice mound-shaped symmetric distribution. Now when we are talking about z-scores, this is referring to really a position in the distribution. So we have our mean, and it's always from the mean. You know, this value over here has some distance from the mean, which can be given in terms of a z-score. Now, z-score is based on mean and standard deviation. So what we're going to need is both the mean and standard deviation for this data set. Now, we can do that most simply with our 1var stats. And again, showing you how to use the calculator. To do a frequency table, we have to give it the intervals, comma, frequencies. So it's 1var stats L1, comma, L2. And when we do that, we see that mean is 50.8 and standard deviation is 13.5. So we have 50.8 and 13.5 for our standard deviation. Now, if we look at a number line, right, which would be really the same number line that the histogram was on, right, middle of it would be 50.8, that's our mean. And if we had a value, say, of 70, right, then that position has a z-score, right? Z-score is multiples of standard deviation. So really it's talking about, you know, how many standard deviations is 70 away from 50.8. So to figure that out, we of course have to find the difference here. And so we would do 70 minus 50.8, which would be 19.2 2, I believe, is the actual distance that we've gone. Now, the question is how many standard deviations is that, which will be your z-score. So all we have to do is, how many standard deviations go into 19.3? Well, that's a division question. And if you take out your calculator, like I am doing right now, and do this division, then the z turns out to be 1.42. So that's 1.42 times standard deviation away from the mean. And you can do that, of course, from both sides. Now, let's maybe do the opposite. Right? Instead of giving a number and figuring out what the z-score is, how far is it from the mean, let's start with the z-score and figure out what number would that be. So let's say we're going to go, let's say our z is 2.25. So we're going 2 1/4 standard deviations away. So, and it's going to be to the left, which means subtraction. It's, decreasing. So really what this is going to look like, it's going to be 50.8 minus 2.25 standard deviations away. So 2.25 times 13.5, this is going to be 50.8 minus 30.375, which turns out to be 20.425. So again, this is actually the value we get, which is a distance of the given z-score. So it depends what you are given and what you're asked for. In this first one over here, we were given the value and asked how far, what's the z-score. And so we got the difference and figured out how many standard deviations go in. And the z-score is 1.42. Here we were given the z-score and asked what value would be that far away. And so we did 2.25 standard deviations from 50.8, and we got our value. And really that's all there is to z-score. It creates a convenient way to find positions in your data.